The graph shows how the pressure P of a sample of fixed mass of an ideal gas varies with volume V. Temperature at A is 85 degrees Celsius. The gas can change its state to that of point C, either along route ABC or route ADC. Question A. Calculate the temperature of the gas at point C. Since the mass of this gas doesn't change, we can use PV over T is constant directly. It means that P at A, V at A divided by T at A is equal to P at C, V at C over T at C. Or you may write P at A, V at A is N R T at A, and at C the same at C, P at C, V at C is equal to N R T at C. N is constant because mass is constant. To get simultaneous equations and then dividing both sides, you get the same. And then just solve for T, C, cross multiplication, or you can move factors along diagonals or flip both sides and then multiply by P at C, V at C to get finally that T at C is equal to what? P at C, V at C multiplied by T at A divided by P at A, V at A, and substituting values we get that P at C, P at A, it's 1.9 over 1.3. This factor 10 to the power 5 cancels because it's the same for both. It's not necessary to write it. And multiplied by V at C, V at A, it's you can see it's 4.5 over 1.5, and again factor is the same, it cancels, and multiplied by temperature at A. And notice that if you meet just temperature, it must be in kelvins. If you meet change in temperature, it may be in Celsius or in kelvins, because number is the same for both kelvins and Celsius, degrees Celsius. So it must be 85 plus 273, and we get that it is equal to 1570 kelvins. And if it is required, you then convert into degrees Celsius. You just subtract 273 and it is equal to 1300 degrees Celsius. It is not specified, so we can give our answer in kelvins or degrees Celsius. It doesn't matter, but here it must be kelvins. If you if you want to get the answer to be in degrees Celsius, here you substitute in kelvins, get answer in kelvins, then convert in Celsius. So initial Celsius into kelvins, give answer in kelvins, and then convert into Celsius. And question B. Compare without any calculations the work done and the thermal energy supplied along route ABC and route ADC. So there are two ways how to compare work done. The first way, it's just we know that work done, it's just area under the curve for PV graph. So we can say that work done is equal to area under the curve, and area, since area under ABC is greater than area under ADC, then work done for ABC is greater than work done for ADC. Or using formulas, you remember that work is what P delta V provided pressure is constant, or work for ABC is equal to work for AB plus work for BC, and work for ADC is equal to work for AD plus work for DC, and work for AB is equal to work for DC and is equal to 0, since delta V is equal to 0 for both. And work for AB, not AB, BC. BC, it's P BC and delta V BC, and work for AD is equal to P AD and delta V AD, and from the graph delta V for BC is equal to, since delta V for BC is equal to delta V for AD, but pressure for BC is greater than pressure for AD, hence work for ABC is greater than work for ADC. And then when about the thermal energy supplied, formula is change in internal energy plus work done, and we know that change in internal energy is directly proportional to change in temperature. Formula is given in the data booklet, and delta T is equal to Tc minus Ta, and is the same for both, and hence delta U for ABC is equal to delta U for ADC. And using the previous result, since work for ABC is greater than work for ADC, hence energy supplied, thermal energy supplied for ABC is greater than thermal energy supplied for ADC. And that's all for this question.